Yeah. Hi everyone. My name is Bhushan. I am from IS India. So we are presenting a topic on introduction to be a battery management system and also designing of the battery management system using MATLAB and Simulink. So battery management system is a plays a crucial role in EV and also battery because to monitor the data like a voltage and current and temperature. So then only we need to make a algorithm to write algorithm to make a safer position to limit the temperature, voltage, and current in the safer position in the battery. So what are the topics we will in this session will be like introduction to the BMS and why BMS is most important for my lithium and battery. We need to know that because why you are using this BMS, why not any other microcontroller systems like Arduino or any other system to control the parameters like and features of the BMS. What are the features will be there in the BMS? So like monitoring and safe temperature monitoring also there and safety and fault detection isolations. There are a number of techniques and features are there in the battery management systems. And after that, you will go for the block diagram. So what are the block diagrams and how the process will be done in the battery management system? And topologies. So like topologies means like how many cells can be connected in series to get a type of like if you have been go for the 60 volts or 70 volts, so we are using for some type of topologies. If you go for the cars, yeah, and also like communication protocol, what are used in battery management system, and and also self-monitoring techniques. What are the techniques are used for the battery management systems and measurement of voltage and current and temperature in the battery management systems, how they are calculating and how they are estimating the voltage and current. And finally, we can see the modeling of the battery management systems. How will we model the battery management system using MATLAB and Simulink? And first topic, first is introduction. So why we need a battery management system? What is a battery management system? So like a battery management system is the heart of the brain of the battery because it is also monitor the a number of things like a voltage and current and temperature, and also fault isolation will be done by the battery management system, and it is to like a ensure the safety, efficient, and reliable operation should be maintained. And it will main important thing is optimize the battery life and performance. So this is the introduction to the battery management system, and also when going to the next slide. So why is most important for the lithium and battery? BMS is why is most important because if you're not present in the BMS, what would be happen like? So there will be a chance of the fault detection. If a fault is detected in the systems, there is no any controller will detect. So that will leads to the fault in the system. That will leads to the fire results in the system and blast in the battery. And there will be like
கால ஒரு வாட்டமா வாங்குது பாரு எங்க எனக்கு ரைட் வாங்குதான்
hello, please stop your mic. And also like battery state of charge and state of health is very important to know the we need to know the how much charge there in the battery while you are riding or any other place. So if you not know the charge, how much charge is present, so that will lead to the stoppage of your vehicle in the middle of the roads and either. So we need to know the state of health and state of charge in every time. And also like we need to battery management system need to communicate with the charger. So if a overcharge will be done, so overcharging or over discharging will be done. So then there is a chance to the degradation of the battery So there will be like a self degradation will be started, and self heating will be goes in the state. So that will lead to also fault in the, I mean, raises the fault, and also like a fire results will be happening in the battery. So like we need to see these features, like a temperature measurement should be no, and also protection will be done, and overcharging and over discharging will be monitoring in the battery, and like a battery like information like a state of charge and state of health will be monitor in the system. So that's why we need, most important thing is battery management system for the lithium ion batteries. And also like not only in lithium ion batteries, and we can use it in the any other battery, because it's very important for a safer operation and optimization of the battery. And also like features of the battery management system, like I before you tell that, we need to monitor the cell balancing, we need to monitor the state of charge, and like protection functions like overcharge and over discharge and over current and over temperature, and communication interference. So what does mean like cell balance? Why you not done the cell balancing means, so if you're not cell balanced, there is a potential difference between two voltages will like not equal. So what happens, there is a chance of the fire in the system. So like if some in battery pack there will be some 3.6 to 4.2 is maximum voltage. So if some battery is not connected in series, like some battery will like a 3 volts and some battery will be like a 4.2 volts. So there will be no balancing, imbalance will be happen, there will be a chance of the causing of the fire also. So that's why we need a cell balancing, and also state of charge and state of health. Before I tell we know to know the how much charge is present in the battery. And like when you comes to the state of health, like it's measuring, estimating like the warranty of the battery. So how much cycles will be come after charging and discharging, like a duration, like a warranty will be say in the common terms, we will say the warranty of the battery. State of health will be comes under. And also communication interference. Why you using the communication interference in this system? Like we need to communicate with other, I mean, battery management system. We need to communicate with the motor, because how much power we need to deliver in the certain instant of time. So like if you have been needed how much torque, then how much power will be required. And also we need to communicate with like a keyboard, I mean like display and other systems also. So that's why we need communication interference. And like also safety. So most important thing is safety in the battery present, because like if you not maintain like a proper safety in the battery, that will lead to the state of health. And state of health will be like a goes down, and also like a warranty of the battery will be lifespan of the battery will be decreased. So and also like block diagram, so what are the systems will be there in the battery management system? So like a sensors. So why we want to sensor, we need to like a voltage and current and temperature, we need to sense the data from the inputs. Like you need to use the sensors like a thermistors, like, and also like user resistors to calculate the current in the system. And also like microcontroller block is also there. Microcontroller, what you have seen is controlling the system, and also like a decision making. So when you have to take a voltage system, and when you have to drop the charging circuit, disconnect the charging circuit, when you have to like provide a charging to the system, and also process the data, like communicate with other systems also, we need to do in the MCU. And activators like a relays and MOSFETs, relay the switches. So we need to like, in some cases when there is a charging and load is also connected in series in the line. So like if a MOSFET, two MOSFETs will be there in the line, because one MOSFET for charging, one MOSFET will be for connecting the load. If one, I mean like a process will be, if MOSFET one is turned on, that like will be charging. MOSFET two will be turned on, that will be like discharging the load. So that's why we are using MOSFETs in the BMS. And also CAN protocol is like a communicate with the other systems. And also like why we are using CAN, because CAN is a very robustness and also like very efficient, and they are communicate with everything without any disturbances, without any like forgot, I mean, like clipping the data of the signal. That is a 100% pure, and also 100% signal will be received from the data. So like this is the like block diagram. You see like see battery pack. So this in this here cells are connected in 18. 18 cells are connected in series, or any n number of cells are connected in series. So then after that we need to determine the temperature of the every cell. So because temperature is very important role, it plays a very important role in the system, and also voltage. Voltage, and we on every cell we need to know determine the monitor this voltage. So this data will be goes to the measurement. So measurement like microcontroller, and also like in also we can use the analog front end. So analog front end in the system you can use for the estimate the voltage and current from the we are getting from here is analog, and that analog front end will be like that, converting the analog signal to the digital signal to give the input to the MCU microcontroller. And also like in this microcontroller will be decision making, like if a temperature will be high, so there will be a chance of the fire will be there, so it will be stop the discharging of the battery, or other it will be like a cooling. Other ways will be detected, like some decision will be flow. And also like after that this measurements we can like a state of health and state of charge and the thermal management systems and everything will communicate will we get from after this block. And CAN protocol will be like communicate with other systems. And like a cell balancer will be done here. Cell balancer will be done every time, because if you're not cell balancing will not done, there is a potential difference between two cells will be like not proper. So that will cause us to the fire hazards. And also discharge circuit is also there. Like we need to discharge the supply by, because cell balance is done by discharging the voltage in the from higher voltages to the lower voltages. That's why we use the discharge. So this is about the block diagram. We are using sensors and microcontroller attenuators and protocol in the battery management system. And also like topologies, why you are using topologies, battery management systems, and what are these topologies are there? Like centralized topology and master modular. And why you have been used this? Because in the battery packs there is a number of cells and connected in series. So there will be a 12 cells, or there will be a 13 cells, and 15 or 100 cells will be connected in series. But we need to divide in the modules, because we need to get a accurate data. Like we need to get a accurate data in the voltage, in the sense of voltage, the current, and any other parameter. So if you are connecting series of 100 number of cells, and directly you are measuring the voltage, the current, and anything, so that will chance of the low accuracy will be get. So that's why we are dividing the cells in 18 cells, 18 and 18, and after, and like 56 will be cells, then 18 threes are around, we are 3 modules to connect 56. So like that we divided. Centralized means like a centralized topology is like a for battery pack which are having consist of the 18 cells or less than 18 cells in series. So then we go for centralized system, like very simple, and we didn't have anything like robustness. And we will see the master also, then we know the how it is simple, centralized how it is simple also. And also like centralized system is like only for e-bikes are small battery packs, energy storage. We can use centralized, not for the cars and other systems, large energy storage banks. And also like after this block, like after 18 cells are connected in series, like we call it centralized. After we will go for the analog front end. So analog front end will be read the data, and that will goes to the microcontroller, and that will process the data, and also like make a decisions. Then we get the state of charge and state of health and thermal management systems. All the things will be then, I mean, after microcontroller, that will be like a output of the system. So this is the block diagram, and structure will be in the centralized. And when it comes to the master and slave topology, like master slave topology, like not in 18 cells, that will be like you can connect it in 100 cells and thousands, like greater than 7,000 cells we can connect it in the master slave in series. But what happens is we are divided, we have to divide it 18 cells in one part, 18 cells in one second modules, and 18 cells in third modules, like divided to up to 7,000 cells. So then we connected to the analog analog everything similar but here is in modular like a and with we need to like a separate microcontroller and after that lost this all microcontroller and we need to connect with the master controller. So this is the modular and also like see communication protocol. Why you need to use it for the communication protocol is communication is a set of rules. Like we need to make a decisions in like uh,
Sir, voice is breaking. Hello.
in the battery management system we are using protocol, control area protocol, because control area network is very robust. Before I do see like it can like communicate with 1 to 2 and 1 to 3. So 1 to 2 and 1 to 3, but also like without I mean disturbing any data, any noise in the frequency of the signal. So and also like you can see that CAN H and CAN L is a protocol, and absolute voltage difference between these two. There will be generation of the signal, and also like the communication between touch screen and keypad will be done with the signal, and the communication between touch screen and also battery will be done. So there is a no interaction. There is a no interruption between any signal. So if you connect n number of series, n number of connections there in the CAN protocol, there is a no disturbance will be happen. That much burst and that much efficient will be happen in the CAN protocol. And UART, universal and asynchronous receiver transmitter, like this is used but for low frequency ranges, not for a good high frequency ranges. And also I2C and SPI also not for high frequency ranges, no, not used in the electric vehicle battery management system. So and also like CAN protocol having yeah.
Sir, I think your screen got unshared. Now it is visible.
Yeah, okay. Yeah, and also like a protocol like CAN protocol and like we really have a robustness, and like we can use like UART also, and also like I2C also, but the frequency range for matches will be only CAN. And also like this is about for communication protocol, and like a battery information. What are the like what you are seeing in the display? Like a state of charge will be in the electric vehicle. We are seeing the state of charge, because how state of charge, because that we know that how much charge is there present in the vehicle. So like based on the charge, we need to move forward, because if you 0%, the vehicle will not be move forward. And if you have been charged for the 100% and above 100%, then we will need to disconnect the charge. So this is the common process we need to do. Like, and what is the state of charge and how you calculate this? Like, so if you know that formula is there, amount of charge remaining the battery to the total capacity. So like, and this is a normal formula and normal sentences definition for the state of charge. And but there is a technique to measure the this data, like a voltage transmission method and Coulomb counting method and Kalman filter method. So voltage translation method is like that. We need to connect the every cell. We need to connect the every cell measurement of voltage. I mean, we need to measure the voltage by using voltmeter. Like that only, we need to measure the between two terminals, but not connecting any load, any charger, any load or anything. Without anything, we need to measure the charging. We need to measure the voltage. So that voltage, after that, we need to calculate the estimation of this estimation of some formulas. We need to like estimate the SOC. I mean, in this process, we need to have some errors there. There is a lot of error is there. You can go through the documents, and we have a lectures on the voltage transition method also, like and 3 to 4 videos are there, and wow, the variation is there compared to other best methods. And Coulomb counting method, like how much charge is going to the how much current in and out is going into the battery. Like if you see that 150 ampere hour capacity battery is there, so you are charging the battery. We are charging the battery like 5 amperes up to 6 hours. So like that, what happens is 5 amperes out to 6 hours means 5 into 6, 30 ampere hours you are charging for the 6 hours. So we know that how much charge is present in the battery, like 30 ampere hour, and total capacity is 150. So like like one third of the one fifth of the we have been charged the battery. So this, like we need to calculate the Coulomb counting method, how much charge is present in the how much charge is present in the in and outflow. So by based on this estimation, we need to calculate the Coulomb counting method. And Kalman filter, like, so this is the best method in the SOC. So this will based on this battery model, like voltage, current estimations. We need to calculate like that. So based on these parameters, VIT, voltage and current and temperature, we have some formulas. We need to estimating that we need to there is an algorithm is there. So then based on that, we need to calculate the SOC. There will be a Kalman filter, there will be the prediction is there, and also like a estimation is also there. So based on these differ from these two values, we need to find the SOC. And Coulomb counting method is also not that much efficient, because we need to here is input is ourself input there. We are considering the input. If you're not, if you're not 5 amperes is not possible to go every time. There will be 4 amperes will be done. There will be 3 amperes will be go in the charger. So what happens? There is a chance of the error in the system. So like that's why we are not using Coulomb counting method and voltage transition method. And also like Kalman filter method is best suitable for the SOC. And this is the basic formula, like CC means charge present in the battery and total capacity into 100%. And SOC, remember every time SOC is present in the in percentage. So this is about the battery information. And cell monitoring technique, like there will be a like why you need to cell monitoring, why you need to do cell monitoring, because if a mismatching voltage between the cells, two cells, there will be cause of so what do you do with this problem statement? We need to or other, like we need to discharge the cell. So these two ways to need to cell balancing the technique. If a higher voltage is there in the battery pack, what you do is like we need to discharge the battery. If a lower voltage is there, then you need to charge the battery. Like this is the only principle. So like passive cell balancing, like what it does mean, like passive cell balancing using the resistors or inductors, any other system. So to discharge the cell voltage, like if you are having 4.2 volts is there, I mean 4.7 is voltage is there, in somewhere like 3.6 voltage is there in second cell. So what you do is like first cell we need to discharge to up to 3.6. And only you need to like balance the cell 3.6 or 3.6. Otherwise, if in second cell is 3.6 volt is there, so then you need to charge the voltage for up to 4.2. So that will not possible in every time. We need to not charge every time the battery. So we need to like discharge the higher voltage to lower voltage. So that will done by the resistor. That will run by resistor, inductor, or capacitor. That will call as a passive cell balancing. If we add to cell balancing comes under like a, we need to use like a DC converters. We will make that if a higher voltage is there in the one cell one. So if a lower voltage is there in cell 3, so we need to take the voltage from the cell 1 and gives and again charges to the cell 3. So what happens is there is an equilibrium, there will equal charge will flow in the system. So this is a complicated method, but you are used in large energy storage applications like a cars and trucks, and like a passive cell balancing, like a use it for the two-wheelers and like battery packs, because passive cell is the very cheapest and like cheapest, and also efficiency is also good. But in resistor, while you using resistor, there will be a chance of heat produced in the system, because that load will be transferring through the current will transferring through the at resistor, there will be chance there is will be heat will be produced in the resistor. So that will also increasing thermal management system. Also, the temperature will be increases. So there is a certain disadvantages also there in passive cell balancing. So that's why we not go for a bigger applications. We not go for passive cell balancing. We will go for the active cell balance. So this is about cell monitoring technique and charge and discharge current, temperature and measurement technique. Like how you measure the charge and discharge current in the battery. So we need to measure. So because how much current will be going to the battery, we need to know. So if you do not know that, there will be a chance of high voltage will be high current will be flows to the battery, and there will be imbalance will be between the cells, between two cells, and will be cause of the fire. So in every time, everything the fault will be occurs if anything is wrong. So how you are estimating the charge and discharge current? So shunt resistance method is also there, and all of it sensor is a method is also there to estimate the charge of the battery, and also like how this methods will be go working. In shunt resistance method, will the current is flowing through the system, current will flowing to the resistor, then we calculate the balancing current. So that's why how much balancing current will be required for the cell. So in this process and estimation, we will calculate the shunt resistance method. When we'll go for the all effect sensor, so all effect sensor like a voltage is directly proportional to like when you place in the magnetic field, difference between the two voltages that will like causes of the some signal. Based on that signal, we will measure the voltage and that will calculate it to the current. In this way, all of our sensor will be done. All of our sensor will be done used in mostly because that will be very accurate, and because we know when you use the sun resistor method, when you use the resistance, there will be heat dissipation will be done. So there will be chance of the fire heat. There will be chance of the increasing of the temperature in the battery pack. So like a temperature measurement technique, like why you use the temperature measurement? Because definitely a very important thing is the battery is temperature. Based on temperature, we need to keep a temperature of the battery in safer position, because there is we are using resistors and cells. So there is small amount or small to medium amount of the voltage, voltage and current and temperature will be releases from everywhere. So what will it cast if it imbalance between anything? So there will be a chance of the self-heating state that will goes to the thermal runaway. So we need to measure every time and every instant of the time what is the temperature will be like. So that Mr. like this is also resistor. In a resistor, we need to cover like use in NTC like a negative temperature coefficient. So that then negative temperature coefficient is resistance is inversely proportional to temperature. If a temperature will increase, resistance will decrease. So we will keep that resistance to measure the temperature. So like uh, so, and designing of layered battery management system using software like a MATLAB and Simulink. And also, we have designed the course for the battery management system with how to design the battery management system. What I'm say before that, the conditions like a cell monitoring technique and also passive cell balancing and everything. I have made the simulation for the everything, and also like um, and also like design the battery pack, entire battery pack based on this, and also how will be like a state of charge, how will be like happening in the SOC, and also like another systems how will be a state of charge will be happen. I will done the every simulations in this and in the course, and this is about the course, and this is about the content, course content for this like and if you have any doubts, please ask me. Hello. Someone is asking like, can we use a sodium batteries instead of battery? Can you use a sodium batteries instead of the battery management system? Like how it is possible? Like sodium batteries are different and battery management system different because like sodium battery. What I mean, what motto of the battery management system? Like, can we like a thermal management system? Thermal management would be easier to for sodium. Yeah, it's easier, definitely. But while coming to the sodium batteries, there will be like disadvantages in the like there is the chances, not I mean there is a chances of eating self-eating state in the sodium batteries, and also in a lithium ion batteries are having a high life cycle, and also like safer operation will be like a safer operation will be done. I don't think like thermal management system would be easier for the sodium batteries. Um, any other question?
Anyone having doubt, please ask your question from our expert. They will guide you much better. For course related, we will share a QR code. You can scan and fill your inquiry form. Okay, that QR code will be shared at the end of the meeting. If you have like any question about regarding this topic, you can ask here.
Yeah, any queries in the regarding battery management system, and there will be I mean I will explain the introduction only. You can go through the and also you like there I will explain only introduction part. So there will be like more topics in the battery management system. So I will be controlling the everything, and also like I design system. I mean in my course we are designed everything regarding how the techniques are used in the battery management systems. How we have estimating the voltage and current, and also state of charge in the systems. And if I mean apart from this, do you have any questions regarding? So only demerit is energy density for the sodium, and remaining properties are also almost similar to the lithium. I found a research paper. Yeah, definitely. Yeah, I mean sodium batteries, because I mean this is the problem now. Energy density. We need energy density more, because if you are like a bike, we need to pull because of based on energy density. How much energy is giving in part of second. So if you have been using, if you have been lithium ion battery only one pack for the 48 volts or 24 ampere capacity, we need to same capacity sodium battery, that like a three cells we need to require. I mean space we required is large, because if energy density is low, so the capacity of the battery will be increases. I mean the space of the battery will be increases. So that will leads to dynamics, vehicle dynamics, and vehicle dynamics improve the weight of the vehicle. So that will not much effective. But your question is definitely good. Energy density is low, and we can use the sodium batteries. But lithium ion batteries have high energy density compared to that, like a 250 kilowatt hour per kg. Yeah. If any other questions, fees. Okay, we will play a center of excellence video of our co-host.
Yeah, okay, Mr. Bhushan, thanks for hosting the webinar. Your expertise and insights were invaluable for our learners. And thanks, learners, for attending the webinar. I hope this webinar helped you out to upskill your learning and skills. I would like to take the opportunity to introduce our company ISIE India products and services that we offer in electric vehicle technology with small video. So kindly have a look with this small video.
As we are living in the fast changing world of electric vehicles, ISA India is leading a tech organization, paving the way for innovation and devotionalizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, IPCA Laboratories, etc. And with national partnerships such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, e-bike design challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, Indian Star Award from Earth Day Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youths for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicle, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational NSQF courses align with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero Motocorp, with Government of Kerala in partnership with MG Motors at two locations, IIT Mandi, private universities like SRMU, Kalgotias University, Sharda University, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus center of excellence worldwide. With India rapidly moving toward an electric-only future, ISA India is well positioned to develop a workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks, learners, for watching the video patiently. So don't miss out the exclusive opportunity to discover the endless possibilities of electric vehicle. So and if you want to enroll in the electric vehicle or interested to set up labs in the institutions, kindly send us inquiry through a QR code displayed on your screen and take the opportunity towards a more sustainable and exciting future. Thank you so much, learners, for joining.
Thank you.